assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This problem is asking us to find the rotational inertia about an axis through a center of mass of an oddly shaped 10 kilogram object that's supported by a wire. The wire has a torsion constant of 0.5 Newton meters, and the pendulum oscillates through 20 cycles over the course of 50 seconds, and we're trying to find that rotational inertia. So eventually we're going to be using the equation T equals 2 pi the square root of inertia divided by torsion. But before we can do that, we have to actually figure out what our period is. So we need to solve for t first. And we're going to use the information that we've been given. We know that the object oscillates 20 cycles over the course of 50 seconds. So we can our period is 50 seconds, takes 50 seconds to have 20 cycles. So we get that our period is 2.5 seconds. So now we can take that information and go ahead and plug that into our equation here. So we'll have 2.5 seconds equals 2 pi divided by the square root of inertia over torsion. And we can rearrange this to solve for inertia, which is what we're trying to find. And we'll have that inertia equals torsion times t divided by 2 pi squared. So when we plug in our values, we have our torsion is 0.5 newtons per meter times our 2.5 seconds, which is our period, divided by 2 pi squared, and that gives us a value of 0.079 kilograms times meter squared.